Okay, we are doing skill 7.4 take 2 because the first time I did this, I forgot to turn on the microphone on my iPad. So fun times, I get to do it all over again. So here we are going to factor each quadratic equation, but they're all simple trinomials, which means that we should be able to factor out any number and only have like an x squared or an n squared as our first term. Now this very first term, we can actually look for common factor of 2a and 2a. And if I do 2a squared divided by 2a, I just get a. And 10a divided by 2a is just plus 5. Now, that 2a doesn't go anywhere. We have to write it outside. It's like an anti-distributive property. So it's like 2a times a plus 5. And that's it. That's our answer. For number 12, this might be the most missed problem of the whole test, which was kind of surprising to me because I didn't realize it was going to be that tricky. But we have a common factor of 2. And so once again, we pull that out and we get n squared minus 9. And then from here, we can factor, remember, this is a perfect square, so n squared is just n times n is equal to n squared, and 9 is 3 times 3 is equal to 9. So we have what's called a difference of two squares. And so that factors into, I do 2 times the square root of n squared is n. The square root of 9 is 3, so it would be n plus 3 times n minus 3. And that is our answer. Now, for when we come to solving a quadratic equations, we need to get everything on one side. So I'm going to subtract 3r, subtract 3r. When you write it, you want to be careful. R squared minus 3r minus 28 is equal to 0. Now, notice that I have the r squared followed by the r and then finally the term without any variables at all. And that's always the best way to do it for consistency's sake when we're factoring. All right, so for r, we just have an r and an r. This is kind of more relevant for 7.5, but it's still useful to write. And then for 28, okay, and now you could do plus and minus with these. I'm just going to do it without the plus and minus, so I'll actually show you that. It takes up a little less room. 1 and 28, 2 and 14, 4 and 7. And so now I'm looking for a pair that subtracts, right? Because one has to be positive, one has to be negative to equal 4. So if I go r here and r here, 4 and 7, so it wants to be negative r. So I'm going to make my bigger number negative in this case. And this is 4r negative 7r, and that adds to equal 3r. So then when I write the value, I would say r plus 4 times r minus 7 is equal to 0. Now at this point, you can do a quick check and just FOIL. R times r is r squared. R times negative 7 is minus 7r. R times 4 is plus 4r. And then 4 times minus 7 is minus 28. And then when I check that, in fact, is r squared minus 3r minus 28. So that works. It's always a good idea to check your work. So since we're good here, I'm then just going to say r plus 4 equals 0 and r minus 7 equals 0. And so then minus 4 and r is equal to negative 4 plus 7, r is equal to 7. And these are my two answers. So we end up doing the same thing for problem 14. I'm going to put this here where I would add 72, and I get 2x squared minus 24x plus 72 is equal to 0. Divide by 2, divide by 2, divide by 2, and divide by 2. Remember, we have the 0 divided by 2, which is why we don't even have to factor out. We can just divide everything by 2 because it's an equation. And I get x squared minus 12x plus 36 is equal to 0. Now here I have a positive number, an x squared. Now you could, so you have an x and an x. Now you could do all the factors of 36. 1 and 36, 2 and 18, keep going. But one of the factors of 6 is 6 and 6. 6 times 6 is 13. And whenever you see this where our first term, x squared, is a perfect square, and our last term, 36, is a perfect square, skip all of that and start with this 2 6's like this, because often when you see this, it will be a perfect square trinomial. Now, because this is minus 12, technically it's not 6, 6, it's technically negative 6. So all of these should have been negative. But this is negative 6x, negative 6x, and of course that adds together to equal negative 12. So I get x minus 6 times x minus 6 is equal to 0. You could also write it as x minus 6 squared, like that. And now you don't actually need to split this into 2 because they're both the same. So you can just set it up as x minus 6 equals 0, and x is equal to 6 is the answer. And you only need to list the 6 once. You don't need to list it 2 different times.